Hi, Wally Taylor from Texas Integrative Wellness, and I'm continuing a topic that I'm really interested in, and that's the mitochondria. I want to talk in this short video about some of the mitochondrial nutrients that are unique to the mitochondria and why they're important for your body. As I was saying in a previous video, the mitochondria at one time were thought to be free living structures, much like bacteria, that later were engulfed by our mammal cells and took up a synergistic symbiotic relationship. One of the reasons we think that is that there's some really interesting and unique things about the mitochondria. For one thing, they have their own DNA. They have a single circular strand of DNA that's very similar to the DNA in bacteria. The DNA of the mitochondria only accounts for a small percentage of the proteins and enzymes within the mitochondria, probably only about 13 different proteins, these being the proteins that are most critical for the main function of the mitochondria, which is what we call electron transport. The electron transport chain is a series of enzymes that ultimately produces the molecule for energy known as ATP from hydrogen ions that are generated as we metabolize fats and sugars and proteins. So one of the most critical mitochondrial nutrients is what we call NAD, or nicotinamide adenine dinucleotide. This is probably the most fundamental molecule in the electron transport chain and is necessary for shuttling hydrogen ions for the function of production of ATP. But in addition to NAD, which is critical, and it's a member of what we call a redox pair, NAD plus, which is the oxidized form of NAD, and NADH, which is the reduced form. But this ratio of oxidized NAD plus to NADH is really critical to the function of the mitochondria. You might hear people talking about redox potential and how important that is for body function, almost in the same way that pH, or the acid-base balance of the body, is also very critical. So for the mitochondria to function normally, several things have to happen. But for one thing, we know that the nutrients that the mitochondria are going to be burning to produce ATP have to be able to cross the mitochondrial membrane. And there's actually two mitochondrial membranes, or a pair, the outer membrane and the inner membrane. And it's this bilamellar or two membrane structure that is critical to their function. So first, we know that the nutrients have to cross the mitochondrial membrane to get access into the mitochondria. So in the case of fatty acids, which the body would want to burn for ATP energy, it's a requirement for a little molecule called carnitine in order to help transport the fatty acids across the mitochondrial membrane. Carnitine is two amino acids connected together, and it's found a lot in meat, hence the name carnitine or carne. So carnitine is a very important nutrient for normal mitochondrial function, especially when it comes to burning fat. We also know that because of the importance of the mitochondrial membranes, there are some nutrients that are parts of the mitochondrial membranes that are critical for normal mitochondrial health. And there's some very good studies to show that when mitochondria don't work or become dysfunctional, they often have very abnormal appearing membranes. But some of the key components of our mitochondrial membranes are phospholipids. And one of the key phospholipids is a molecule called phosphatidylcholine. Several foods are rich in phosphatidylcholine, like egg yolks. And it's oftentimes very valuable to support or replace and supplement some of these phospholipids in the form of phosphatidylcholine. The fatty acids that are also important in the membrane are cholesterol and the omega-3 fatty acids, which you can often source from marine oil. In addition to supporting the mitochondrial membranes for mitochondrial health, we know that there are some other enzymes and cofactors that are also very important to support normal mitochondrial function. We know that the coenzyme CoQ10, which is critical for normal function of the electron transport chain, is also a critical mitochondrial nutrient. PQQ, or pyrroloquinoline quinone, at one time thought to be a vitamin, but now known to be cofactor, since it is capable of being manufactured within the body, although it's difficult and is often rate limited, is another important mitochondrial nutrient. Another nutrient that's pretty important for normal mitochondrial function, because it's so important within what we call the Krebs cycle, which is how we burn fats and sugars, is alpha lipoic acid. Alpha lipoic acid is a coenzyme for a very important enzyme called pyruvate dehydrogenase, and it also plays a major role as one of our body's main antioxidants. Alpha lipoic acid is a fatty acid that contains sulfur, and it's both fat soluble and water soluble, which allows it to work in both compartments. So these are some of the most important mitochondrial nutrients that are necessary for normal mitochondrial function. What I've learned, though, in my practice of environmental medicine is that simple replacement or supplementation of mitochondrial nutrients can sometimes be very beneficial in helping to restore function. But very often we find that it's other factors that are primarily contributing to the mitochondrial dysfunction, particularly what we call the mitochondrial cell danger response and toxic effects to the mitochondria from petrochemicals, toxic heavy metals, and even biological toxins. So I've learned that simple replacement of the critical mitochondrial nutrients may not be enough to restore good mitochondrial function and normal ATP levels. We'll be talking about my approach to the cell danger response and to elimination of some of the toxins affecting the mitochondrial function in upcoming videos. Well, I hope you got a little bit out of this. If you do, please consider following me on my YouTube channel, watching some of my other videos on chronic illness, and please feel free to share this video with friends and family. I hope you have a blessed day.